All right, so this is when we start the lectures. These particular set of slides is about 40. I'll probably do 20 now, and I will be moving between this and drawing in another slide to really make sure we all get it. Okay, so this is the closest we can do to get to a classroom situation where I can draw on the classroom on the blackboard or the whiteboard. Okay, so for this week and next week, we'll be talking about the foundations of micro, specifically for industrial organization. Okay, so let's talk about the fundamental concept of market demand. So we'll be talking a lot about market demand from now until the end. Okay, for this course, we'll be talking about linear market demand functions. So now we have a market demand of this form usually. P is equal to A minus BQ. Now this is just a simple equation. You can do this in X and Y. Okay. In particular, P is in the Y-axis and Q is in the X-axis. This is basically the intercept, and B is the slope, or minus B is the slope. When price is at the left-hand side, when written this way, it's called the inverse market demand function, because typically when we think about demand, we think about Q as a function of P, but it's the inverse demand function when P is a function of Q. Okay. Now there's a one-to-one relationship between market price and market output Q. So that's why it's a function, and it's a simple line in usually in our case. For this class, typically for advanced applications, it's going to be almost linear anyway, or linearizable. It could be non-linear entirety, but it could be within the area or the neighborhood of the equilibrium, it's still linear. So these are the kinds of things that we're working with. So that's why we're simplifying things further by making sure, by assuming that the entire thing is linear. Okay, so what can we think about when we think about market demand? When we think about market demand, you can think about this as an aggregation of each consumer's willingness to pay for a product. So what would be happening here is that for each consumer who is willing to pay 1 unit at price P, all of those consumers will be added up as the market consumption or demand. So you can imagine, at different price levels, there will be someone who shouts the price is P, and then the number of people say, yes, I want to buy 1 unit at P. Yes, I want to buy 1 unit. Everyone gets added up, and that's the quantity for the market. Now here's the inverse market demand, which is exactly what we were just talking about here. Okay, now A is the y-intercept, and that's just the maximum value for 1 unit of consumption. So if you think about it in terms of the example we had earlier, where you had a population of people and they had different willingnesses to pay, A happens to be the willingness to pay for the person with the most or highest willingness to pay for the good. So at price A, he or she alone will buy 1 unit of the good. Okay. And as the price goes down, more and more people are willing to pay for the good, because it's now becoming more and more likely that the price is less than the maximum willingness to pay. So that's why it's sloping down like this. Okay, so that's what you would think about when it comes to market demand. Okay, in particular, any given price P1, and there's a price P1 here, that's the marginal consumer valuation of consuming an additional unit when the output is Q1. So in this situation, imagine we are at Q1, and then the person who last decided to buy at Q1, his willingness to pay has to be at least, cannot be less, has to be at least P1. So in order to move beyond P1, you have to set the price to be a little less than P1. Okay. If you want to move a little beyond Q1, you have to set the price a little bit below P1 to attract the willingness to pay for these people on the right hand side of the curve here. Oh, hold on. Okay, equilibrium. Okay, there are two time frames that we'll be talking about in class, in micro generally, short run versus the long run. The short run, and the difference between the short run and the long run is that the difference is that in the long run, new capital and labor can be brought in and new firms can enter markets. So in the short run, no new factors of production can come in. So you guys know what a factor of production is, right? In order to make something, kailangan mo ng inputs. You need workers, you need machines, okay? You need electricity, right? And in the short run, the quantity of all of those inputs is sort of frozen or fixed. And in the short run, it's really just you and me and everyone dividing the short run output, right? That's the purpose of the price. How are we going to divide the short run quantities of inputs to produce our output? Okay, so that's the difference between short run and the long run. Okay. In the long run, no new inputs can be brought in and no new firms can enter the markets because no new capital can come in. So we have an equilibrium in either time frame. We have a short run equilibrium and a long run equilibrium. An equilibrium, the word equilibrium merely means that no consumer or firm will choose differently in how much to buy or sell. Okay, so for now, we will focus on what's called a short run equilibrium. Okay. One key assumption here moving forward is perfect competition, at least for this part of the course, right? Understanding perfect competition is necessary for us to really understand monopoly power and market power. Okay. What does perfect competition mean? This just means that each firm and consumer cannot affect the market price. This must mean that each firm or consumer's output or consumption is small relative to the size of the market. So one of the things that I always think about here is like a pool of water. Okay, if you put your finger in a large pool, nothing happens to the height of the pool, right? Nothing happens to, you don't displace enough water for the water level to rise appreciably. Although it does, right? It doesn't do so appreciably. So it's the same thing with perfect competition. If there are these small farmers, small traders, small retailers who would say, okay, the price of a bottle of water is now 25 pesos. Okay. That's just the price for that person or that company or that seller. And it's not the price for the market. The market will ignore a unilateral setting of price or quantity from those people, right? From those perfect competitors, because they're small relative to market size. Okay. In the same way that your finger is small relative to the size of the pool. Now, if everyone is this small, there's no strategic interaction for each consumer or firm. So my actions to sell or not to sell, or to sell this high or to set a price this way, has no effect on any other firm. So there's no strategic interaction. Okay, so that simplifies the analysis, but that also makes you realize how the equilibrium would happen here. That all of the equilibrium decision making is inward looking. You're just looking at what will maximize your profit faced against a market price that you cannot affect. Okay. All right. So let's talk about optimization for sellers. Each firm would like to sell such that it would maximize their profits. Total revenue is capital P, where capital P is the market price, and small q is the sales by any given firm. Total cost CQ, that's a function of only its own production. So it's a C as a function of the small q. Consider selling one more unit of Q from Q0 to Q1. Think about it in terms of marginal revenue. Okay. Marginal revenue in terms of formula, you can think about it as the change in revenue or total revenue divided by the change in sales. So the change in revenue is just the change in TR here, as you can see. And the change in TR is just this one, based on this formula up here. And if you simplify a little bit further, it's this, P times whatever the change in quantity is. So from the point of view, I just want to focus on this one. From the point of view on the seller, he wants to sell more, no problem, right? Because the more he sells, the more he will earn. Because for each unit that he sells, he will sell P. And because his output is small relative to the size of the market, he will not really change the market price P. So he might as well sell everything that he can get away with at the price P. Okay, so what is the marginal revenue? We're just going to follow the formula. Change in revenue divided by the change in sales, which is this. There's a calculus definition for this. Maybe in the homework, we'll discuss that. And then that's just this by using our calculations. This is the numerator and this is the denominator, the change in quantity. And the marginal revenue is just equal to price. So each additional unit of output will net you the price P, which again, because of the assumption of perfect competition, doesn't change, because the output of each small firm is not enough to affect that P. Now, the optimal quantity is set by equating marginal revenue to marginal costs. Think through this intuition. If selling one more unit of Q gains you P greater than the marginal cost of selling one more unit, would you sell more or would you sell less? Right? So clearly you will sell more, right? If the price or the return to selling more is greater than the cost to selling a little more, then you would sell more. And if it were the opposite, it would be the opposite. You would sell less. Now, what is marginal cost? Let's talk a little bit about marginal cost. Marginal cost is found in exactly the same way. Marginal cost is just this change in total cost divided by the change in output. Okay. What sort of assumptions do we make about marginal costs, or how it's shaped, right? What is the shape of the marginal cost? So it's a function, as you can see, right? It's an output. It's a function of how much produced. Okay. So of total production, Q. Okay, it's a function of total production. It could be a constant. Okay, but what is the assumption that we've got moving forward? We will find that we have marginal costs is a function of Q, and that's it's non-decreasing. It's either constant or it's rising in total output, Q, at least around its equilibrium point where MR is equal to MC. If it were decreasing, can you imagine an MC curve that goes down, right? If you can imagine an MC curve that goes down, that would be very nice, because the more you sell, the less cost it is for the marginal unit. And remember, if P is constant, nako, that means your profits per unit will actually be growing as you're selling more. Okay, so that would be very nice for that firm. As you can see, that's probably not the case, because if that's the case, then everyone would sell a lot, and then that would basically change the way we would think about the model, because if everyone sells a lot, then suddenly the price atomistic price assumption, the perfect competition assumption, becomes less tenable, because the more you're selling, that doesn't mean you're remaining small relative to the size of the market. Yeah. So that makes the perfect competition assumption less attractive if MC is in fact falling throughout the entire Q. Okay. So we'll have it that the marginal cost is at least flat or rising, especially around the equilibrium point. So the short-run equilibrium is illustrated here at PC and QC. At PC and QC, MR is equal to P. Okay, so let's look at it. This is the firm here, and this is the marginal cost. QC is here, and PC is here. PC happens to be the marginal revenue, and it's equal to marginal cost at exactly that quantity, QC. And in fact, that's how we get the output per firm, because we're equating the price to the marginal cost, and that's how you get QC. Now, the question then becomes, how do you get PC? If for each firm, the PC is something that's given, something they don't control, something that they just look at, and then once they look at, they decide how much they produce in response to it, where does P1 or PC or P1, PC come from? Well, PC comes from the market demand, which in this case is D1. Okay, so this is the original market demand curve for PC. Okay, associated with PC. And as you can see here, at PC, the total quantity is QC, big QC. Okay, and there are n different firms, each producing small QC. Then big QC is just QC, small QC times n. And that's n times n sellers. Okay. And in fact, that big QC and that n QC, that's essentially this guy here. This is the supply function for the industry. This one. Now, it should also be obvious that this supply function for the industry is really just the horizontal summation of the marginal cost curves. So all of these ones is just basically all of the marginal costs for all of the n firms. In fact, you can imagine there's a marginal cost here, right? And then you're just adding horizontally all of the different marginal costs. So there's a marginal cost for this guy, right? And then 2QC is here, so there's a second marginal cost for 2QC. And then over here, there's a third marginal cost for 3QC, etc., etc. So the supply curve for the industry is just the horizontal summation of all of these marginal costs for each of the different firms that you're adding horizontally. Okay. But that goes to the original question, where does the PC comes from? It comes from the intersection of the industry supply and the market demand. And that's internally consistent with each firm, because now each firm is looking at that PC and it's producing exactly small QC, which is totally consistent with big QC, which is just n times the small QC. Okay. So this is the short-run equilibrium under perfect competition. Now, what happens when there are changes in demand? So this exact same picture also illustrates what would happen. So the first thing that would happen is if demand rises, it would shift the industry market demand from D1 to D2. And it would intersect S1 at a higher price point, at a higher quantity, at Q1 and P1. Now, since each of the n firms sees P1, now they're moving up their marginal cost function, moving up the industry supply curve. Each one is producing now Q1, and the industry is now producing big Q1, which is just n times Q1 here. Very, very easy. In fact, that's exactly how this line, this S1, is produced, right? Because this is just n times whatever the small q is. Okay. Now, the higher market price at P1, well, we already discussed this. Each firm would sell more at a higher output Q1. Big Q1 is just n times small q1, which is greater than QC, which is n times Q0. So this is basically the same thing as what we've learned in basic econ. If the market demand shifts to the right, then the equilibrium market price will go up and the equilibrium quantities will also go up. And that is just reflected here at the firm level. And that's the purpose of the left-hand side picture here. Next, let's talk about the long run. The long run is defined as another equation, which is P equals average cost, a function of quantity. So AC is average cost as opposed to marginal cost for MC. And AC is also a function of Q. Okay. Note that P under perfect competition is just P, just a number. It's not a function of anything. Okay. It's definitely not just a function of Q. So that's the point. Okay. Especially from the perspective of each individual firm. Now, AC means average cost. The long run is when there are, no. I should write no. Excess profits per firm, right? If it's equal, if P is equal to AC. Note that if P is greater than AC, then PQ is greater than TC, which means there are profits per firm. Now, when price rises, as long as MC is greater than AC, and this is a very interesting condition, we will return to this in a couple of weeks, okay? But we will basically assume this for now, and we'll see that it's necessary later. There will be excess profits, right? When price rises, as long as MC goes up, there will be excess profits because prices should equate MC, right? Under equilibrium, P is equal to MC. And if P is equal to MC, then MC is greater than AC, then that means P has to be greater than AC. Excess profits. Okay. Now this condition of MC is greater than AC is met if the quantity is high enough such that MC is greater than AC and MC is rising around the equilibrium quantities. Again, that's something we'll talk about later when we talk about technology. Extended periods of excess profits encourage entry and will shift the industry supply to the right and lowers the market price. So let's take a look at what that means in the picture. Now this is the long run equilibrium. We start again at S1, right? But what he said was the industry supply would shift from left to right. From N firms, you would go to higher than N. Okay, say N something, N1. Okay. And that starting at P1, there's this excess profits because P1 is greater than AC at Q1, which is this point that I'm pointing to here. And this, in fact, this rectangle here is a rectangle of the excess profits enjoyed by the firm. Now the the industry supply curve will shift to the right by exactly enough to lower the price P1 back to PC. Okay. So S1 will move to S2 such that P1 will go back down to PC. But when price goes down to PC, then per firm output goes down from Q1 to QC, right? Now you must be wondering, how can we produce more if per firm output goes down back to its old position to QC? Well, the answer is there's more firms. At QC here versus this QC prime, this QC has N firms. And remember, because of the increase in demand, there was excess profits. There was entry of new firms. Then this vertical gap here between QC and QC prime, that is born or created because of the number of new firms greater than N. So there's more firms now. So a higher number times QC is now equal to Q prime C. That's how, in fact, you would calculate what the total number of new firms is. Right, because it would go down exactly. The supply curve for the industry would shift to the right exactly to make P1 to P0 again, which would create QC as QC prime as a total quantity. To get the total firms, you would then have to compare this Q prime C to this QC, and that would be the difference between the N prime, the new firms, and the old firms, which is the N. We'll probably be talking about this in a homework or group exercise at some point, where we will talk about what the new quantities are, new per firm quantities are, what the profits are, and so on and so forth. Okay, so I'll be finishing this particular video on welfare. Okay, so this is the standard picture for welfare that I'm sure you have seen. Okay, so the welfare triangles are determined by using the industry supply and market demand curves. At PC and QC, the consumer surplus and producer surplus is maximized. So check it yourself. When Q1 is less than QC, determine the areas of consumer surplus and producer surplus. Okay. So at any point less than QC, you'll find that there will be a triangle here that will be lost. Okay, portion of consumer surplus will be lost, and a portion of producer surplus will be lost because output is less than the competitive level here, QC. Now, this time choose OG, which would be greater than QC. What would be bad with that? Start from the industry demand. What is the marginal willingness to pay for the QGF unit? Okay, so if we wanted to have an output, industry output higher than the competitive level, you could say, okay, let's have output equal to QG, but the willingness to pay is just PG, right? But the firms require a higher price here, which is indicated by this F, which will say, PF. PF is clearly bigger than PG. Okay. So what would be bad for that? In order for the firms to be incentivized, they would have to be paid the difference between PG and whatever the new one is, the new price is. Because in order to produce this much, they have to be sold. Their selling price has to be this level up here. So that has to come from somewhere, right? That has to come from somewhere. And the idea is there's taxation and subsidization in order for firms to produce all the way out here and for consumers to consume all the way down here, right? Okay. So what would be the problem with that? Okay, there would be an increased consumer surplus, right? There would be an increased producer surplus. However, this entire region here especially would be considered to be a subsidy, right? You'd have to pay a subsidy equal to the difference of the prices here and the difference of the quantities. So someone would have to pay for all of the other areas here, right? So the required subsidy is GF, FH. Okay. Consumers gain additional surplus C, B, and G. C, B, and G. And the remaining part of the subsidy equal to triangle BTF, BHF, I should say, this one, okay, is the deadweight loss of resources, right? Because of that subsidy. In order to convince producers to sell this much, you'd have to pay that much, right? And that is more than the increase or the level of producer surplus, which would be this upper triangle, and the increase in consumer surplus, which would be this lower triangle. So this triangle on the right, which is B, F, and H, that would be the deadweight loss from the policy. Because why would it be considered a deadweight loss? Because these guys don't really want to pay for the product, but they're being forced to. And these guys shouldn't really be producing these output because the cost of producing these exceeds the benefit from the people who are buying.